Okay, ladies and gentlemen, example 2 from section 6.3. I've gone ahead and filled in some of these values. So what the question says, the shape of a bridge can be modeled using the quadratic relation y equals 25 minus x squared. Notice that they're using the word quadratic, and that's because there is an x squared term in it. They wanted us to complete the table of values. This is what I did without you. So the x is -3, -2, -1, 0, 1, 2, and 3. They gave us those values, so I plugged them into this equation. So it's 25 minus -3 squared, 25 minus -2 squared, 25 minus -1 squared, and so on. You may want to take a moment and just pause and fill in this chart for yourself. Once you do that, you're going to be looking at plotting the points. So I just plotted the points. I decided that I would use my axis here. And I have 1, 2, and 3 going this way, -1, -2, -3 going this way. And I did a break in my scale here. So this distance doesn't equal the same scale going up here. So we start at 16, and I go to 18, and then 20. So I go up by 2's here. But this is a break in the scale, meaning that the distance here doesn't relate to this distance up here. I then graphed all my points. So I had -3, 16. I had -2, 21. I had -1, 24. And I had 0, 25. And then you'll notice that something happens. It's symmetric. The same pattern happens over here. 1, 24. 2, 21, 3, 16. And that's what's happening because we've just crossed the axis of symmetry. So we have some things that they want us to identify. They'd like us to identify the X and Y intercepts. That's a little bit more challenging than one might think with this graph. First of all, for the X intercepts, for an x-intercept, y must equal 0. And y equals 0 isn't on this curve. Y equals 0, well, and it's not on that curve because the points that they gave us doesn't include the point where y equals 0. So y equals 0 is happening if this curve continues. And it will continue, but we don't know what those values of x that make y equals 0 are. So we have a couple of choices here. We can look at this and do a bit of a guess and check. We can say, okay, what value has to go in for x so that when we take it away from 25, it'll give us 0. Well, if you know your perfect squares, then you know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, but 5 squared is 25. So it is very, very true that if I put 5 in for x, then I'm going to get 0. Now, that's a positive 5. It's also true that if I put in a -5, I'm going to get -5 times -5 is positive 25. So 25 minus positive 25 is 0 again. So my two x-intercepts using this method are going to be x equals positive and -5. And that's how we'd write that if we wanted to look really cool, positive and minus. Now, there's another way to do this. We can say y equals 25 minus x squared. We want y to be 0. And then just use our algebra skills that we have. The x squared is negative, so if we add x squared to both sides, then we square root both sides. But remember, I taught you earlier in this course that when we square root both sides, we have to take into account the positive or negative. So it's both going to be plus or minus 5. So those two ways to get your x-intercepts. Now what about your y-intercept? Well, your y-intercept, I think we can read right off the graph. It's occurring at 0, 25, so it's going to be y equals 25. Okay? So for your x-intercepts, y must equal 0. For your y-intercepts, x must equal 0. So I've done the first one, I've done the second one. What's the third question? The coordinates of the vertex. Well, increasing, increasing, increase as I read left to right until I hit this point, then decrease. So my vertex must be 0, 25. And you'll notice that it's the highest point. My parabola opens down because there's a negative in front of the x squared. See that negative? So it opens down, and if I'm going to open down, then I'm going to have a maximum. And that's important when you're dealing with your vertex. Always tell me whether or not it's going to be a maximum or a minimum. What's the third thing it's asking for? The equation of symmetry. Well, the equation of symmetry always runs through the vertex, so I can look here, and it's always going to be the y value, no, the x value, sorry. So the equation of symmetry, remember, is going to be a vertical line, so it's going to be x equals 0. Or we can see it up here. There's that symmetrical line that it's crossing through, and it's going to be x equals 0. All right, that's example 2 done. I'll stop here and we'll finish off with section 6.4.